All right, today's lesson is about multiplying complex numbers. So the first thing we're going to look at is the warm-up here. By definition, I is equal to the square root of -1, which is just I. If we square each side of the equation, so we take this and we square each side of the equation, that's I squared. Well, if you square the square root, it cancels out. The square root symbol does, so you have -1. All right, so I is equal to the square root of -1. By definition, I squared is -1. If we multiply I squared times I, we get I cubed, which is the next thing I want to do. I cubed is I squared times I, or multiplying -1 times I. So it's -I, or -1I, either way. Then if we do I squared, that is I to the 4th power. Well, if you square this, it's a -1 times a -1, which is 1. So I to the 4th power is equal to 1. So those are the definitions that we'll use periodically through the class. So here they are again. I is equal to the square root of -1, which is just I. I squared is this times itself, which would be -1. I cubed is -1 times I, which is -I. And I to the 4th power is -1 times -1, which is 1. So these are up on the board behind where I sit normally. So the warm-up here is to write each of these in A plus BI form we're just simplifying each one of them. So we have 3 times 4 is 12, so it's 12I squared, which turns into -1 times 12, which would be -12. So this times this is 12I squared, and then the I squared by definition is -1, so it turns into -12. So it's -12 plus 0, I. So write each expression in A plus BI form where A and B are real numbers. So there's just no imaginary part. And it's going to be like that on all of these, I believe. So let's do number 2 together. So we're going to do the -3 times the 4 would be -12 I squared. I squared is -1 times the -12 would be 12 plus 0I. So it's just 12 this time versus -12, and then there's no imaginary parts. Okay, try the next 3. And here we go. So we have, by the way, you're supposed to pause the video there and try them. So we have this times this is 10I squared, which would be -10 plus 0I. And then we have this times this, which would be -25I squared, which would be a -1 times I would be 25 plus 0I. So they're trying to drive home the point that the imaginary part disappears. And then a negative times a negative is 25I squared, but then the I squared is -1, so the negative comes back, that pesky negative, and there we are. So there are the 5 answers. So this next part here is just a whole bunch of matching, and basically I squared, right, is -1, so this should be -3. So this is equal to -3, so that's gone. We just did I cubed. I cubed is -I, so that would be this one down here, so it would be -8I. And you can go through and see how all these match up. This one here, there's no I squared, it's just going to be 35I. So that one's gone. Where this one here, it's going to be an I squared, so it'll change back to the negative, so it'll be -35. I to the 4th power, I defined that on the other page, that's 1. And then I squared is, this is a little tricky. I squared is negative, but with the negative in front of it, this is also 1. So we can use the answers more than once, it looks like. And then this one here would be -1. Yeah, because it's going to be I squared, which is negative 1, because the negative gets squared. And then this one here, you're going to use one of them, but you're not going to use the other one. So that's kind of the deal with this. This would be 9 I squared. I squared is negative 1, so this would be negative 9, not positive 9. So that one didn't get used. So that's the matching part of this. So it's kind of like the warm-up, but it's matching. And then I also gave away the fact that, you know, these things keep popping up. What is I cubed? What is I to the 4th? Okay, now the heart and soul of this section. We're going to multiply these together. So number 1, I'm going to make a grid here. So I like to have the single thing in front. So I'm going to recopy it this way. And then I'm going to make a little grid here, like 1, 2, 3, 4. So I like to have the single thing in front when I multiply, so we're going to distribute through the parentheses, just like we normally do. We think of the I as like an x, so I times I is I squared, x times x is x squared. We just treat it the same way. So this times this would be negative 15i. This times this would be 45i squared. And I've done this 100 times with you. I squared is negative 1. So this is going to be negative 45. Then we always write it in the form a plus bi. So this is negative 45. That goes first. So negative 45 minus 15i. And then it's in the form a plus bi. So it kind of matches that form. This will make even more sense when we start solving quadratics. Number 2 is a full-on like FOIL situation. First, outside, inside, last. We did this a whole bunch of time. I used colors, and the first color that I always used was green. Green means go. Oh my gosh, my green pen has run out of ink, so I must find a green pen. Hang on, pause. I am back. We have green now. So multiply those two together. First, outside, inside, last. So this times this, right? Negative 40. This times this, plus 24i. Okay, now we're going to go to the inside. So green means go, and then we do red, right? So I times that. Think of that like an x. I times this would be negative 5i. This times this is plus 3i squared. Put together our like terms. But then also, this is going to match up with the 40 here in the front because we just did this, right? I squared is negative 1. So negative 1 times 3 is negative 3. So this turns into negative 3. The negative 3 is going to go with the 40 in the front that's negative. All right, so here we go. So I squared is negative 1. This is now changes to negative 3. And that's different because, like with x's, you just leave it x squared and you're done, right? But the I squared is negative 1. All right, so our final answer is negative 3 with the 40. With the negative 40, you borrow. You owe how much? 43. And then you have 24, you spend 5, right? 19i. So there we go. Negative 43 plus 19i. Okay, next time, number 3 here, we're going to do the same thing. It's squared, so we're going to write it down twice and then FOIL it out. 3 plus 2i. 3 plus 2i. In some ways, this is easier because it's the same thing times the same thing. You don't have negatives or anything. So why don't you give this one a try? So pause the video, give it a try, and then we'll go through it together. All right, here we go. So this times this, green means go, 9. This times this, plus 6i. All right, and then on the inside, this times this is another 6i. And then this times this would be 4i squared. There's the I squared. The I squared is negative 1, so this is negative 4 now. And it's going to go with this 9 in the front. And then the i's go together in the center. Put your eyes together. So it'd be 5 plus 12i. So then again, it's in that form a plus bi. Number 4, 3 plus 2i times 3 minus 2i. All right, so this right here is the thing where the middle part cancels out, right? That pattern a plus b, a minus b, the middle part always cancels out, if you remember that. Because it's exactly the same, but they have the plus and minus, which makes the middle part go away. So here we go. Green means go. So 3 times 3 is 9, just like the last time, and then minus 6i, and then a 6i here, and then a minus 4i squared. So it's just like this one over here, except for the signs are a little bit different. So what's going to happen this time? That's -1 with the -4. That makes it be 4. So this is positive 4 with the 9 in the front, right? So the 9 and the 4 go together. It'll be 13. Uh-oh. And then that part, whoop, goes away. So this answer is just lucky 13. Amazing. All right, this is the orange page on page 340. And basically, they just show you how this gets multiplied out, right? Green means go. First, boom. Outside, boom. Red pen. Inside, boom. Last, boom. Okay, so then you put your like terms together, and they do all that, and then you end up with this answer here. Because these go together, making 22, right? And then that's negative 15 with the 8 in the front makes negative 7. So there's the final answer. Multiplying complex numbers. So this one here, the purple page, you're going to just distribute through, find the answer. Here's one of these where we added and then we multiplied. Here you're going to multiply this one out. This is a review from earlier in the unit. All the students know the exponents E-I-E-I-O. So 729 to the 2/3 power. So it's E exponent index. So you're going to take the cube root of this number and then square it. So which one is that? Calculator can help you out with that too. This page here, we're solving these, and this is a review questions. It was like on the quiz. And basically what you need to do is you need to break this up into 3 parts. So we get 2x squared minus 2/3 is equal to 5 1/3. So you're going to add over and then divide by 2, take the square root, plus or minus 2 answers. B, x plus 1 quantity squared is equal to 81. Right away, you're going to take the square root of each side. And don't forget that yields, that can be plus or minus. So you're going to have x plus 1 is equal to plus or minus 9. And then this one here, we get 3x squared plus 14 is equal to 12. Okay, when you subtract the 14 over, something special is going to happen, right? So you have to think about that. Okay, plot all of these on the complex plane. Plot all these in the complex plane. So basically you got the real axis this way and the imaginary axis this way. So 5i is just going up 5, right, on the imaginary axis. And then again, this is a plus bi, right? So you're going 2 spaces in the real direction, and then 4 spaces in the imaginary direction. So 2 spaces in the real direction, 4 spaces in the imaginary direction. So that's how you do this one, 2 plus 4i. All right. The last one, number 7, I always try and give you a hint with these, like how many of these are true. So this goes back to unit 2, but it's basically just asking you to multiply these out. So you're going to multiply Green means go. First, outside, inside, last. But there's other ones that are equivalent to this. So let me give you a hint on how many are true. All right, there are 3 answers that are equivalent. Can you find them all? That's your challenge. There are 3 answers that are all equivalent to this. Peace out.